All right, hopefully you can't hear the sounds of the video going on next door. I want to talk just for a few minutes about the correlation coefficient R that we just talked about. The first thing you need to realize is that that number is always between -1 and 1. And when R equals 1, you should think about this as a perfect fit. And in this case, there is what I'm going to call positive slope. It's a little bit more nuanced than that, but it's essentially positive slope. When R equals -1, again, you have a perfect fit, but there's negative slope. There's an inverse correlation is the way that people often talk about that. And then if you get a correlation coefficient of 0, then you should think about this as, this is sort of the worst case. No, we'll just say no correlation. Worst case scenario. Okay, so I've got a picture to show you. And here's, I pulled this from an open source book. I think it's just called Open Stats, I believe it's called. I'll try to put the link in these notes so that you have a source. Anyway, you can see here, you know, if you try to find the line of best fit, we can kind of guess somewhere in there it's going to fall. And the correlation coefficient is not super strong because it's so scattered. Here, the correlation coefficient is stronger because you can almost see this central kind of ladder. Here, this central kind of corridor, excuse me. Here, very, very high correlation because the data is really clustered around this line. Here's a correlation of R equals 1. This almost never happens in practice, by the way. Here's an extremely low correlation, right? You can have all kinds of lines. I can't tell if the best fit's that way or this way. It's hard to say. This is a pretty good correlation, and it's negative. The negative just means the slope is negative here. That's all it means. Think about the 0.64 is actually reasonably strong. Here's a very strong correlation that's negative, and then, of course, here's -1. All right, so let's say one more thing, and then we will hop over to the next video. I need to grab a picture real quick. Let me grab this. Whoops, whoa. I want to copy this, and we'll hop back over to our note. Let me drop this one down. I just want you to realize that you can actually do linear regression. You can find the line of best fit for any data, but you really shouldn't. The data ought to be somewhat linear. Like here's the correlation coefficient, and yet clearly this is not linear. This is quadratic. This is more sinusoidal. There's this bouncing going on, and yet you get this correlation coefficient, and then the same thing here. This is very scattered. So just want to encourage you when you're doing this, you really should have data that looks somewhat linear. If it looks nonlinear like this, there's actually other techniques you can use. You can curve fit this thing to like a -x², or this one might curve fit to a sine x, or so on and so forth. I won't talk about that, but the point is it can be done. All right, so let's jump to Excel, and then you'll be ready to do some examples, and if you want to tackle the bonus homework, then you can.